Say something, Jen. No. Yes, I don't doubt you can. Isn't this what happened last time? Like at first your sound didn't work either? And okay. That's what I thought. Hmm. Hello, Candace. Hello, Myra. Welcome back.
Hello.
Is Jen talking?
Not yet. She's still figuring it out. So
Oh no.
that's okay. She'll figure it out. She's awesome like
Yeah, it's true. That's so weird.
I don't know. It's super weird. Jen always is one of the problems too. Okay. So
Okay.
set no 6 first, right? Preparation assignment.
that. Okay.
Yeah.
Okay. Does anyone have any questions before we start going over stuff?
Let me.
It's a lot less basic than before. So.
Yeah, it's just kind of more of the definition ones. Those aren't bad. So I went to a website. It was like random.org or something where they just randomly picked numbers, and so I got the 5, and I got 43,640 for my mean.
Uh-huh.
Mine was 47,900.
Mine was 43. I printed out that paper. I should have read ahead and saw that you're just using it for one question.
That's all right.
Yeah.
And you're just supposed to put where on that graph was.
Do you know, like, is there a certain line where it's close to the mean or not close to the mean?
Certain line, the mean, well, like, it's just whatever's closest to the middle. So, like, it says, does your sample mean appear to be unusual? And, like, explain why. I'm pretty sure it's just whatever, if it's close to the middle, then it's normal.
I didn't know if I, like, missed that there's, like, a specific number or something.
I remember in the video that it was, like, the middle, like, the 4,600, like, the middle.
Okay.
So, right between there, there's, like, 2 lines that are, like, right in the middle.
Yeah.
So, like, in the video, the guy had, like, 47 something and stuff, and so he put it as, like, normal, which is closer to 4,600, which is the middle of the mean, middle of the curve.
Yeah.
And stuff. And what did you guys say that yours was?
Mine was 43,740.
Mine was 43,640. So mine was kind of near, the edge on the left side. So I was actually wondering the same thing, if there was like a certain area where it wasn't usual anymore. But I saw the video too, and the guy didn't really mention anything about it. So
If it was unusual.
yeah.
Yeah, well, I guess because it does tell you to explain your answer, so I guess there's not really a wrong answer.
Yeah, like the answer sheet just says answered very, answered.
Yeah.
Yeah.
So,
All right.
okay,
So
so
there's that one, and then D. Well, I guess we just compared, right?
yeah.
Okay.
Okay. So we don't have
So
to.
like Stephanie and Jen's were kind of close, and then me and Myra had pretty close ones, and they were on opposite sides of the mean, which is pretty interesting. There.
That's true. So number 8.
Okay.
Let's just go to number 8A. What is the shape of the distribution of the sample means for all such samples? I put normally distributed.
Normal.
Me too. Yep, because the parent distribution was normal.
And then B, how do you know that the distribution of the sample mean has this shape? And I put because it is greater. Well, what did you guys put? So I can not make myself read it that my answers.
No. The same as I said, because the parent population is normally distributed.
That's exactly what I said.
What did I put? Okay. What is the mean of the sampling distribution of sample mean scores for all such samples? I put mu equals 529.
Yeah, because that's the mean that they gave us, so.
Yeah. I felt like that question was weirdly worded. I had to read it a few times.
I feel like this
Well,
whole
I felt so stupid when I figured it out. I was like, it's right there. Okay.
Yeah. I feel like this whole chapter was weirdly, like
Yeah.
the questions were, like they gave us too much information and tried to confuse me, you
I think in
know?
a way it's just fluff words that they throw in there, fancy words that don't really,
I know, I'm like, ugh, like I know they're just tricky, you know?
Yeah.
Yeah.
They keep around the bush until I get to the point, kind of.
Yeah.
All right. So what is the standard deviation of the sampling distribution of the sample mean scores for all such samples? I put 35.734.
Yep, that's what I got.
Okay.
Me too, yep.
Cool.
So it's standard deviation divided by the square root of n, right?
Yeah.
Okay.
Are you good, Jen? You got it? Okay.
Just very dramatically nod.
Yeah. Yeah, there we go. Rock.
Are you there for that one?
Oh, Jen, we miss you.
No. Pretty voice.
So do
Okay,
we want
go ahead and do lesson 6 homework.
homework?
The quiz, the group quiz?
Yeah, the group quiz.
Oh.
Sorry.
That's fine. I was like, I didn't do the homework.
I know, I'm like, wait. Yeah, should we start?
Alright.
Okay,
Everybody.
so 3.
Okay.
Taking samples of n equals 5. What is the shape of distribution?
So wouldn't that be right skewed?
Yeah, it would still be skewed right because it's a small small sample.
Yeah.
Okay, so it can't be normal. Okay, when taking samples of n equals 100, what was the shape of the distribution? Well, they samples more than 30,
So it's normal.
so it would be normal. I'm confused though, because wouldn't it be approximately normal? Or where's the difference between just normal and approximately normal?
I would just put normal.
Normal? Okay.
That's true. That's a good question. I agree. I don't really get it.
Sometimes it's like it just puts normal and then approximately specifies.
Yeah.
Okay, next one.
I guess it's good it's multiple choice.
Yeah. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed?
Normal.
So yeah, if the first one was normal, then the shape should
Yeah,
be
plus
normal.
the population is big, so that one's easy. Are you still with us, Jen?
Good.
So 6, choose all the correct responses. So data drawn from a population that is normally distributed, and sample size is large.
Yep, that one for sure. So B
So
is
I
for
have-
sure.
I think it's D, too.
Like, I don't know if ours are all in the same order. So you gotta say what it is.
Okay, so data are drawn from a population that is normally distributed and the sample size is large. That one's true.
Yeah. Even if the sample size is small, so the other one that's normally distributed, even though the sample size is small, it's still normally distributed.
Yeah. And then I think it's D also. Data are drawn from a population that is right skewed and the sample size is large, because then the law, is it the law of large numbers? No, I get those two mixed up.
I think it's a central limit theorem.
Central limit theorem. Yeah, there we go.
Yeah.
So we're going to put B and D.
Yeah, so I have 3 of them marked.
Okay, so you were saying that A was true too, the normally distributed and the sample size is small?
Yeah, that's true.
Okay.
Is everybody good on that?
Yep.
Yeah.
Okay.
Explanation.
Which of the following gives the best explanation?
Is it D?
The sample size is large. The shape of the sampling distribution of the sample mean will be approximately normal. Yeah, that's what I put. I think is right.
I'm like checking my notes. All right.
Is everybody good on that one?
Yep.
All right.
Let X be a random variable with population mean 10 and population standard deviation 6. So is that just the mean? So 10?
Oh, yeah, this is that trick question one again, but this one's worded way better.
Yeah, so it's 10.
Okay.
Good catch, man. I was like starting to calculate and stuff.
I get tricked all the time, so I should be pro by now.
The answer's right in front of my face. All right.
So the standard deviation we have to calculate with the standard deviation of population over the square root of n.
So I got 1.
Wait, so number 9, we have to use that one formula to find it?
Yeah,
Yeah.
I got 1 too.
You got 1 too? Okay.
1 also.
Awesome.
And then standard, yeah.
Regardless of the distribution of the population, sample size is large.
That would be normal, right?
Yeah. Because it's large, the sample size is large, and then
Yep.
this limit theorem would apply.
Okay.
Am I right? Jen, Candace, do you want to correct me?
No, I use the central limit theorem.
Okay.
Large numbers has to do with comparing it to the mean. Central limit has to do with distribution.
Wait, are you? Oh, you're on 11 already.
Yeah.
So
So it's central limit theorem because we're justifying why it would be normal in 10.
Oh, okay, yeah. Got it.
Okay, so let's go through and make sure we got them all the same. So 1 and 2 we already got. 3 skewed right. 4 normal. 5 normal. 6 we got A, B, and D. And then 7 we got D. Are we all together?
Yeah.
Okay, 8 is 10.
Uh-huh.
9 is 1. And then 10 is normal. And 11 is central limit theorem. Good?
Yep.
You're
All right.
Also,
Good. 1, 2, 3.
woo!
Woohoo!
Nice.
Good.
All right. Lesson 7. Any questions on lesson 7?
Let me pull it up really quick.
I know that, like, for the question 7, like, if you just look at the 35 and 55, it looks like it's 1 standard deviation away, but when you actually calculate the z-score because of the sample number, it's 2 deviations.
Yeah.
I don't know if everyone else got that, but I got it wrong and then I checked my answers, so.
I guess I did it the long way. I did the huge calculation of both separately.
Uber.
That's what I got.
Okay, good.
I go the long way.
Okay. So, the part 1, anyone have questions?
That one?
No.
No.
Okay.
It was a good review, I thought.
Yeah. The only stuff that I have problems with is the way the questions are asked, because I get confused easily, and then I know how to do it. It's just sometimes I think it's asking for something else, and then I just get it wrong. But
Yeah.
that's the only thing that gets me. Other than that, though, it was a good review.
Good.
Okay, good.
Part 2. So you guys can read that. What'd you guys get for 4?
Normal.
Normal.
Yeah, because the parent population was normal.
Yep. 5. Normal.
Mm.
Yep, because the sample size is large.
And it's normally distributed. Okay.
All right, and
And
then
then
for
it's not
6, I got z equals -1. And then you plug that into the applet, and I got 0.1587 for the probability.
Me too.
Yeah, I just did the 68, 95, whatever rule. So,
Good for you. I'm proud. For some
I
reason,
know.
can't do it that way. I have to do it the long way.
any shortcut I can take, I try to find that first before I try to do the problem.
What do you mean you do it the long way? I just did the z equals 40 minus 45 divided by
That's
the
what I'm talking about.
10 and
Is that the long way?
oh, I didn't know that was the long way. I guess I'm doing it the long way too.
Okay. Well, maybe I'm just calling it the long way. It's just normal. We're good.
Yeah, because what you can do is with the 68, 95, 97.5 rule, because the 40 is one standard deviation away, in between the 40 and whatever's the higher one, there's going to be 68, so then you just take the leftovers on the outside and divide it by 2. That's what I did. But you can do it either way.
Yeah.
Okay. And then the next one, just the same thing, you can do it either way. So I had 0.95 because of the shortcut.
What number? 8. What number are we on?
7.
Okay. So for that one, I did the same thing, 35 minus 45, and then I got -2, and then I plugged it into the applet and shaded the middle. And I still don't get that, sometimes they'll shade the left and the middle or the right and the middle, and I still don't get the difference. Why do we have to shade too?
Because, so I can tell you, so for this one it says greater than 35 and less than 55, so you only want the middle because you want it in between those two.
In between, yeah. That one I get, and then it'll say greater, and it's just the right side, and then it'll say least, and that'll be the left side. But sometimes it'll have me do both.
Yeah, so if the number that it's less than is higher than the average, than the mean, then you need to shade the middle and all the way to the end. Because you're just shading all the way to one side. Does that make sense?
Oh, okay, I didn't know that. So if the number's bigger than the mean.
Yeah, because, well, depending on which way they want to shade it. So if they say everything less than this number and the number's higher than the mean, then you want to shade both of them. Or if whatever's more than this number and it's less than the mean, then you want to shade it the other way. Does that make sense?
Yeah. Okay.
All right.
Jen, are you okay?
Was it just me, or did you guys all just kind of freeze, or was that just on my computer?
I don't know.
I totally missed everything Jen was just saying. Not Jen, Candace.
I see 2 Jens now. Do you guys see 2 Jens?
I see 2 Jens. Can we hear one of them?
I know.
No? Oh.
What is going on?
Okay. Sorry, Jen. I feel bad for you. Just don't worry about it.
At least you're here. That's all that matters, right?
Alright, so number 6, 7, 8. So for 8, I got 0.95.
Yep.
Yeah.
And then 9 was 0.0062.
Yep.
Yeah. And then 10. So it was right skewed because the normal population is right skewed.
I also put down that the sample size was not big enough for the central limit theorem.
Yeah.
So
So do you need to write if it's right or left skewed, or you just put like not normal?
I put right skewed. Just
So did I.
Okay.
And you said you also mentioned the sample size, right?
What?
You said you also mentioned the sample size because the sample size is large.
Oh, I put down that I just added that the sample size was not big enough for the central limit theorem to come into play, so that's why it wouldn't be normal.
That's why I was right. Yeah. Okay.
And I'm pretty sure for you, Candace, if you just put down not normal, you'd know if it's right or left skewed automatically. I'm sure it doesn't matter. So. Okay.
So 11 is normal, and 12. What did you guys put?
Yes, and I put central limit theorem.
Yeah.
Because the sample size gets larger, the distribution gets closer and closer to normal.
Yeah, the way I remember is central limit theorem has to do with distribution, and the law of large numbers has to do with comparing it to the mean.
Oh.
That is good.
Say that again. I'm going to write that down.
So central limit theory has to do with the distributions, and the law of large numbers has to do with comparing sample mean with population mean.
Cool. Circled that in my notes.
All right. 13, I said no because it's not normal distribution. It's not symmetrical or whatever it's called.
Yeah. Alright. For 14, I put down 0.9599.
And so that one was shaded middle and right side. So that one was one of them.
Yeah, because it says what's probability of everything that's greater than this number, and since that number was smaller than the mean, and you're asking for greater, you shade both.
Oh, okay.
You, Mara?
Got it.
Alright.
And 15, I had 0.789.
Yep. I put 788, but I just didn't round it, so.
Yeah, that's.
I put 0.07888. Yep.
Well done. Last quiz.
Oh, we're fast.
We're doing faster than last week. I think last week we at least took an hour.
Yeah.
Jen, are you doing good? I mean, yeah, Jen, you doing good? Okay. All right, let's start it.
All right, everybody ready to start?
Let me pull it up.
So we need the applet for this, so.
Yeah. So, 1 point.
Are you guys cold out there? It's freezing over here.
Today, here in Washington, it was like 55. It was awesome.
It was like a mid-60s all last week, like 64, 65.
Nice.
And then today, it was like 43, and I'm like, oh.
It's like 10 degrees here on a good day.
Wait, are you in?
I shouldn't complain.
Are you in Idaho?
I'm in Idaho. Yeah.
Okay.
I would die.
Explains it.
Drop dead.
I know, but you burn a lot of calories when it's this cold outside. I'll tell you that. I can just eat it. Okay.
I'm confused. Okay, wait a minute. Let's see.
Find the combined area under the standard normal curve that is to the right of z and to the left of the negative one. So it's just the outside ones?
Yeah, so it's 0.1745.
I haven't put it in yet, but I'm sure that's right.
Wait, hold on. I need to do this.
Yeah, so just follow the instructions to the right of the positive number, to the left of the negative number.
So,
Are they supposed to be highlighted at the same time or just take turns?
I think they're highlighted at the same time because it says the combined area.
Okay. So what did you get, Candace?
0.175.
Okay. You rounded it. Oh.
Okay, I got 0.826. I did it completely wrong.
You have it backwards. So so you entered your z, right? The 1.358?
Yeah.
So now you want to highlight the right side of the positive number and then the left side of the negative number. So you're highlighting just the outsides, not the middle.
Oh, okay. So 0.174.
Well, I got 0.175.
When you round it.
Yeah.
So what? 0.17?
0.175. Correct.
You have to have 3 decimal places.
Okay.
Right.
Okay. The United States Coast Guard assumes the minimum weight of passengers is commercial boats is 185 pounds. Previous value was lower, but was raised. Standard deviation of passenger weight.
Okay.
It's questions like that that just get me because of all the info.
Yeah, so you just got to take it one thing at a time. So I always like to read like at the end of the question to figure out what they're asking for. So it says find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in the sample. So the sample that was observed was 177.6.
Yeah.
So we need to calculate the z-score of that.
So would that be minus 185 over 26.7?
So did you say 177.6 minus 185?
Yeah.
Okay, I didn't hear that part, just want to make sure.
I don't know, I'm kind of...
Yeah, so then put it over what?
26.7.
And then divide it by square root of 48?
Yes.
Okay.
Square. So I got negative 1.92.
Okay, wait a minute. How did you get that again?
So because you're taking a sample of it, you have to do the formula, the like more complicated z-score formula.
Yeah.
You take 177.6 minus 85, and then you divide all of that by 26.7 divided by the square root of 48, 48 being the number of people in the sample. Does that make sense?
Yeah.
You want chips and salsa?
Okay, so what did you say you got?
Okay, so for my z-score, I got negative 1.92.
Okay, I got the same thing.
And then when you plug it into the applet, then I got 0.055.
Okay, let me plug it in really quick. .055.
Yeah.
Okay.
Is that what everyone else did?
Yeah. Did you shade?
Don't feel bad, Jen. It's okay.
Wait, why do you... Wait, what did you guys get for in the probability applet?
0.55.
Okay.
Jen, did you get that? All right. No questions on that one?
No.
Wait.
Wait, actually. How do you know what to shade?
So if you read it, it tells you right here after it says extreme or more extreme parentheses, either above or below the mean. So it's on both sides. And in that note, it explained it.
Okay.
Can you guys hear me now?
Yeah.
Yeah. I can.
Oh, okay.
Sorry. I have my iPad going, so it's kind of confusing.
You're fine. You're echoing a ton.
Yeah.
I was gonna say, you sound like a rock star.
It
Let
sounds
me-
really scary,
hold on.
actually. Is it Friday the 13th?
Let me turn it off here. This is weird.
That's good stuff.
All right, are we ready to move on to number 5?
Yeah.
All right, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? I don't know.
Is it C?
Yeah.
Doesn't give very much information.
Yeah, because it doesn't make sense to me, so.
I would say C. Jen, what do you think? I can't hear you if you're talking.
We love you, Jen. You're trying. You're trying real hard.
You still get full points, don't worry.
All right. Then we're good on that one. 6. You are. Don't feel bad. This one's
That
not.
was the law of large numbers, right?
The spread in mean decreases as the sample size increases. Sounds right, because it's comparing the mean.
Yeah.
And Jen, you're contributing, but we mostly are agreeing on everything, so we're not having much discussion. So
So the law of large numbers.
Yeah, that's what I think. Let me look at my notes really quick, because I remember writing that down somewhere.
that's just a weird. See, that's a weird way to phrase that.
I know. Everything is phrased weird.
Because I thought. I don't know.
Okay, so see, I wrote this down. The law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean.
Yeah, so I guess because it's saying the spread of the mean decreases, so it gets closer. It's just saying it in a weird way.
Yeah.
Okay.
All right, 7.
Normally distributed the mean of unpaid.
All right. So calculating her z-score.
So 160 minus 150.8 divided by 8.8. Is that one just a simple z-score?
I think so, because it doesn't give us, it doesn't say she's pulled from a sample.
Yeah. Okay, so I got 1.045.
That's what I got.
Huh?
1.045. Yes. Four, 5. Are we all good on that?
Is that what you guys got too?
I got that.
Okay.
Okay.
And then what is the probability that a randomly selected student will score above 160 on the quantitative portion of GRE?
So wouldn't we type in our last z-score in the normal probability applet, right?
Yeah, because it's the 160 z-score.
And then you just shade the right side.
Yeah. I got 0.1480.
Yeah, me too.
Wait, say that. What did you get again?
I got 0.1480.
Yeah, so I'm just putting 0.148.
Yeah.
Okay.
All right. Your scores are.
So this one, I think we need to use, because it's a sample,
Excel.
we need to use the n in that z-score formula.
So how would we set that up though? Do we do each individual one?
We calculate the mean of those 5 scores.
So in Excel.
Yeah, so add them all together and divide by 5.
If someone read them off to me, 160.
175, 163, 149, 153. Yeah, and so I got a mean for that sample of 160. Do you guys get that?
I don't get it. I'm kind of lost.
Oh. Okay.
I'm typing it into Excel right now, and then I'm going to. I guess I'm doing it the long way, but.
I typed it into Excel too, but I don't get it. I got 2.812. So I know I'm doing it wrong.
No. So I just did the average or the mean of the sample of 5 students.
What did you get, Candace?
I got 160.
That's what I got.
Yeah, and so then you take that and you subtract the, what was it, 157, no, 150.8, and then divide it by the sample, the standard deviation divided by square root of the sample.
Okay, just one more time. You're adding all those numbers together, right?
And then
Yeah.
dividing by 5 to do the mean.
Yeah.
Okay, and then divide by 5.
That equals negative 0.2. Oh, wait, you said after you minus the 150.8 minus the 160, then you divide it.
160 minus 150.8.
Oh yeah, sorry, I wrote that out wrong.
You don't want it to be a negative number.
Yeah.
I got 2.338. Jen, did you get that?
What did you get? Say that again.
2.338. Do you want me to tell you what numbers I used?
Yeah, can you just tell me what, so 160 minus 150.8, that's where I'm at.
That formula where you calculate the z-score with the sample.
Yeah.
Yeah, so it's 160 minus 150.8, and then you divide that by 8.8 divided by the square root of 5, because there's 5.
There's 5 of them? Okay.
Does that make sense?
Yeah. $2.31. You got 2.338.
Yep, that's what I got.
That's what I got.
Okay.
Awesome.
Alright. What is the probability that 5 random...
It'll probably work next week, Jen. It's just today.
answer 4 decimal places.
Okay.
So wouldn't we just type the answer that we got 9 into the probability applet and just shade above that?
Yeah, that's what I think. So if you put the applet z-score as 2.338 and shade just the top most high area.
I got 0.0097.
That's what I got, Jen. Ira?
I got 0.98.
What did you type into the applet? 2.338?
Yep.
And where do you have it shaded?
The greater. The right.
So just what's above it?
I don't know if you can see that.
Yeah, that's what it should be. And so you should have 0.0097. Is that not what it says in the area?
Yeah. That is. I read it wrong. I'm an idiot.
Okay.
Yeah.
I was like, I don't know what you did wrong then.
I just had to zoom in. Apparently I'm blind. Yeah, I got 0.0097.
Okay, good. 11. What is the shape of sampling? It'll be approximately normal, right? Because the
This is
is large.
yeah. The central limit theorem applies. What is the distribution?
Does everybody agree?
So that one's approximately normal.
Yeah, there's the approximately now.
Okay.
There we go.
Yeah, that's the clue.
So 12. What's the name of this one?
Wouldn't it just be 3.5? No. Wait a minute.
Is this applying to the numbers given before? No.
No.
What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? I don't know what they're asking. Jen? I don't get it. You get it.
Well, is it
So I put in my notes, the collection of all possible sample means, X bar, is also a population. The mean of the distribution of the sample means is the population mean, which is...
Oh, okay. So is it just asking you for the mean from before again?
I'm pretty sure.
so 3.5?
Yeah.
These questions,
No.
they word it so
If I got that
weird.
wrong, you guys can blame me, but I'm pretty sure it's just 3.5.
So then it would just be a simple sampling distribution on 13 then?
Well, let's see. It's asking for a number.
I
The standard.
got 12.9.
Oh, you're supposed to use that formula where you take the given standard deviation and divide by square root of n, right?
Yeah. That's what I did.
I got 0.78. All right, hold on. I'll be right back to you.
Okay.
Wait, what did you get, Myra?
12.9.
So wait a minute. You did. Wait a minute. For some reason, give me a minute to figure it out.
Okay, sorry.
Okay.
So did you guys get 0.078?
No, I'm trying to do it again.
Yeah, so I just
Tell me what you did.
0.7 divided by the square root of 81.
0.7 divided by the square root of 81.
Yeah, because the formula is the standard deviation of the population divided by the square root of the sample size.
Oh, I was trying to do the longer one for some reason.
Oh. I don't think that's what it's asking for.
Okay, so I got 0.078.
Yeah.
Okay.
So I think for 14 we use the long z-score formula.
What is the probability that the mean GPA for anyone randomly selected for the lesson? Yeah, we use the longer one.
Okay, one more time. For 13, you said 0.7 over square root of 81.
Yeah.
And you got 0.78?
Uh-huh.
Okay.
So I just calculated the z-score for 14 and I got negative 257. Is that what you guys got?
Yep.
Wait, for
And
which
then,
one?
for 14. And then when I put it in the applet, I got 0.0051.
And it says what is the, yeah, so it's just that one part.
So 14 is just 2.57?
But hold on, for 14 I think we only need to put 0.005.
Okay.
I just don't want you to get it wrong.
0.0051. Oh, just 5.
Yeah. Is everyone good on that? Jen?
Hold on.
Number 14? Okay, so for 14 it says the probability. So I calculated the z-score using the 3.3, but I did the more complicated z-score formula because it's a sample. So you have to do the square root of 81, you know, at the bottom of everything. And then I put that into the applet, and since it's a negative, then yeah.
So the formula looks like 3.3 minus 3.5 over divided by 7, which is divided by the square root of 81.
0.7.
And that's 0.7, yeah, sorry. And that's 2.57. And then we plug it in, and then we get 0.005.
Mm-hmm. Okay, so then this other one is asking us just greater than 3.3.
I got the same thing for that. I don't know if I'm doing it wrong.
Well, you just gotta change what's highlighted. So now it's greater than 3.3. So z-score is going to stay the same.
So 0.051. And then we just change it to...
So I got 0.995.
So what did you guys? Sorry, I'm still on 14. I had to write it out.
Okay.
No, you're fine. So what do you have? What did you write?
For the z-score, I got negative 2.56. And then I plugged that into the probability applet, right?
Yeah.
I got negative 2.57.
Yeah, so did I.
Oh. What did I do?
Yeah, just round it out to 2.57.
Well, like without rounding it, it's negative 2.
Oh.
56410 whatever.
That's a different number than what I had. I have negative 2.571. And so does Jen.
Okay, so you go 3.3 minus 3.5, right?
Yeah.
Okay, and then you divide
0.7.
0.7 divided by the square root of 81, right?
Yeah.
Yeah.
Okay, and then I got, whatever, for the top I got negative 0.2, well, 0.2. Then for the bottom I got 0.078. Did I round that wrong? Sorry, I like split it up, so.
Yeah, I didn't like do them separately, I just did them all together.
Oh. I'm sorry, I'm holding you guys up.
No, you're fine.
Lots of times on the calculator there's like an answer button that you can use, so you can actually do one and then type in another number and then divide by your previous answer.
Oh, I think I just found my problem.
Okay.
Hold on.
Yeah. So Jen, did you get 15? Yeah, for problem 15, did you figure out?
I can't figure out problem 15. I plugged in 0.005 and then
You don't plug it
said
in.
no?
No, see, because look, it's still asking you about the GPA of 3.3. Yeah, what Jen says. So since you had 3.3, it's going to be the same z-score, but you are saying instead of less than 3.3, you're finding out the greater than 3.3. Yeah, I got the same thing as Jen.
So we're shading the right side.
Yeah. Including
with the same z-score though.
Yeah, including the middle, because our z-score was negative.
I still get the same answer. I don't know what I'm doing wrong. Sorry, I'm still on 14.
That's okay.
No, because that. Are you still separating it out?
No, I typed it all in the calculator and stuff. Like, I don't know how to explain it, but so like I do 3.3 minus the 3.5. Got that answer. I guess I am separating it out, and then I get 0.7 divided by the square root of 81, which is 0.078, and then I divide those two together.
Only 0.077777777.
Yeah. It goes like million sevens and then an 8 at the very end.
Yeah, so that if you round that too much, that could give you the discrepancy.
Okay, so how would you have rounded it? Like I put 0.078.
I would just put in as many sevens as I could in my calculator if you want to do it two separate ways.
Okay.
Okay, so -2. I'm like.
Stephanie, are you using the calculator on your phone? Jen.
No, I'm not. It's just a normal TI 36X Pro calculator. But I think I just got the right answer. It's negative 2.57.
Yeah.
So, negative 2.57. Where's my thing? So for it saying that it needs to be less than, that means it needs to be below that, right? So what did you guys get for the probability answer?
For 14, I got 0.005. And then 15 is asking you greater than of the same number, so I got 0.995. Because together then 1.
Yep.
Okay, so I can run through the answers. Do we get all the same answers?
Do we need to put a 0 in front of those decimals? It doesn't matter.
I did. I don't know though.
Okay, let's go through them. Sorry about that.
That's okay. 3 is 0.175.
Yes.
4 is 0.055. 5 is this cannot be determined from the information given.
Yes.
6 is the law of large numbers.
Yes.
7, 1.045. 8, 0.148.
Yes.
9, 2.338.
Yes.
10, 0.0097. Wait. Do we need to round that to 3?
No.
It says, okay.
No, it's 4. 1, 2, 3, 4, 5.
It says round your answer to 4 decimal places.
So 4. Yep, never mind, sorry.
Okay. Everyone good on that?
So
Okay.
0.0097.
11 is approximately normal. 12 is 3.5. 13 is 0.078. 14, what? Okay. 14 is 0.005. And 15 is 0.995.
Tell me 13 one more time.
0.078. And number 8, I have 0.148. I could be wrong. That's just what I have.
Wait,
For number 8, I have 0.148 too.
Are we good on 13, or what? Do I have it wrong?
No, that's what I have too. I just, for some reason, had another number typed up on there, but I had it right on my notebook.
Okay, cool. Then I'll submit it.
Okay. Let's see.
We only missed one.
We missed number 5. That one that we didn't understand.
Ah.
Let's see.
Which bomb was abolished?
If 9 observations are randomly drawn from the
Was that one?
population.
Were we supposed?
I didn't even see that question like when I was doing the other
Yeah, that one's tough.
stuff, so I just figured we didn't get enough information.
I think what it is saying now that I read it again, now that I know the right answer, so if you have a bunch of individuals, they're going to be spread out like all over the graph. But if you take the average between a bunch of them, all their different averages are probably going to be closer together than each of them on their own. I think that's what it's saying. Because remember in the video it showed like 2 at a time, and you would either have these 2, but then you'd have the mean, and the mean was always less distributed than the individual observations.
Huh.
Does that make sense?
No, I don't really get it.
I'm sorry.
No, it's okay.
I'm like trying to figure it out, but.
Did you guys watch a video where he was showing you that weird graph thing where it dropped down like individual observations?
Yeah.
To tell you the mean of them? So when you had like 5 individual observations, you only had one mean for it, and it was in the center. So you have more random ones, and it's in the center. This distribution is a lot smaller than the individual distributions.
Okay, so then you just get more. Okay.
The individuals are going to be more spread out because the sample means are going to be more close to the average. Or you know what I'm saying?
Yeah.
If you watch that video again, I think it'll make sense if you keep this question in mind.
Okay. I'm going to check that out for a refresher. But good job, everyone.
Yeah.
You know.
Great job, you guys.
We'll have to work it out next time, Jen. And
I know.
that is so weird.
You.
Well, at least you were here. That's all that matters.
Yeah.
That she can see that you were in the meeting. So.
But maybe if this happens again, next time we can just call each other and 4-way each other, I guess.
Yeah.
You know, we don't have to see each other's faces. We just need to hear each other, right?
True.
The teacher needs the video.
Well, we'll make a video and then comment.
Oh, yeah. Let's just, yeah.
Okay.
That's right. I, forgot the main purpose of this.
Okay.
All right, girls. Have a good one.
So are we going to meet at the same time on Monday next week? Or are we going to go earlier, later?
I am down for whatever.
Probably we'll try it for earlier, then if we need to take longer, we're good. So do 6 or 6:30, my time in Rexburg.
So 8:30 my time?
Okay. Sounds good.
Yeah?
Okay.
All right, so let's 8:30 my time then.
Okay.
We're going to do 5 o'clock my time. Okay.
Sounds good. Bye, Jen.
Bye, Jen. Bye, Candace. Bye, Sarah.
Candace.
Bye.